In this unit, we're interested in building proteins, and proteins are made from amino acids. In fact, we have 20 different amino acids that we use to make proteins, and it's going to be an awful lot of work to understand all 20 of those amino acids and their properties, and that's what this entire chapter is really all about. Now, think about the analogy we use, that a protein is like a train and it's made up of train cars. There's a lot of different types of train cars, but before we focus on the differences, let's also acknowledge that train cars have a lot of the same things for every one of them. They have wheels, axles, platform, connectors, things like that. So what I'd like to do in this video is talk about the commonalities that we have for amino acids. All 20 are going to have the same core structure. And to understand that, we want to take a look at an amino acid here. This is a compound with an amine and a carboxylic acid. That's where the name comes from. Now, the organizational center for the amino acid is right in the center here, and that is what we call the alpha carbon, alpha being the first letter of the Greek alphabet. Every amino acid has an alpha carbon, and every amino acid has 4 groups around that alpha carbon. First of all, we have an amine, like we said. We also have a carboxylic acid, like we said. Now we also have a hydrogen. Every amino acid has a simple, inert, small hydrogen. And lastly, we have an R group or variable group. That's the part that's going to be different, and we're going to ignore that for now and focus on the rest of the amino acid. Okay, so the first thing we want to address is that when you have a carbon with 4 different groups around it, and those 4 groups are arranged in a tetrahedron, you actually end up with chirality. And what that means is that those 4 different groups can be arranged in 2 different ways. You may remember a little bit about chirality from organic chemistry. And when we look at an amino acid, we can arrange those 4 groups either as an L amino acid or a D amino acid, and those are mirror images of each other, just like 2 hands are mirror images of each other. The first thing we want to point out in this case is that the L amino acids are going to be used in proteins, and the D amino acids are not. That doesn't mean that D amino acids don't exist. They do, but it's the L amino acids that make up the vast majority of protein content in our body. Now, the good news is that we're not going to spend as much time talking about chirality as you did in organic chemistry, and we're not going to make you identify which is the L and the D form. However, it is extremely important in biology to understand that most biomolecules have chirality, and that affects their function. I want you to think about it this way. Think about a hockey glove. A hockey glove is a big, stiff glove, and you can put perhaps your right hand in a right-handed hockey glove, but the left hand cannot go in there and fit. That's because the glove and the hand have chirality. So when we think about drugs and molecules like sugars and amino acids, they have a chirality to them, and they're going to fit in proteins and enzymes and antibodies only that fit their chirality. And that is a very important principle for other classes you'll take, like pharmacology. Let's take a look at a drug or a natural hormone like epinephrine. Maybe you've heard of an EpiPen that is used for people undergoing asthma attacks that can be dangerous. They take epinephrine, which is a natural hormone, and epinephrine has chirality as well. Just to practice this a little bit, I'd like you to pause the video, look at the structure of epinephrine, and identify any chiral centers that you can, and then pick up again and we'll go through that. Okay, remember, chirality occurs when you have a tetrahedral carbon with 4 different groups around it. And it turns out there's only one chiral center in epinephrine. That carbon right there has 4 different groups around it. The carbon just to the right of it does not have 4 different groups because it has 2 H's, so that's not a chiral center. So it turns out there's a left-handed and a right-handed version of epinephrine, and only one of those can act to get your heart beating, to open up your airwaves. The other is pretty much inert. So that's an important principle I'd like you to be familiar with, but it's not going to be one that's a real skill set that we hit heavily. So that's the basic core structure of amino acids. We're going to leave it at that for this video and move on to the ionization of amino acids in the next.